So, very good morning to all. So, today's lecture we are going to continue with the machine tool gearbox. In the last lectures we have discussed about the construction of ray diagram and also we have started doing a problem. So, in this problem we have only done the ray diagram aspect. Today we are going to discuss the construction of a kinematic diagram. I am sure you are aware of that. The kinematic diagram helps to place the respective gears based on the ray diagram such way that to get the desired output for each changes in the gearbox selection. That is the purpose to have a kinematic diagram. I am sure you would remember this is the problem we have been doing. We have completed so far for the ray diagram aspect. Okay. Now we will discuss for the kinematic diagram. So, we have completed the ray diagram here, you can see that, and we need to construct the second part kinematic diagram and the later part discussing about for a number of teeth for each gear in the gearbox. I am sure this is the structural formula, it is given 2 of 1, 3 of 2, 2 of 6 is the structure given formula. And this is the ray diagram we have constructed in the last lectures, and 31.5 is the your minimum speed and 1410 is your maximum speed. Of course, start from here, you must be aware of that the motor speed is 1500 RPM, which is not shown here. We are only focusing about the ray diagram aspects. Okay. So, as you are aware of that, the given structural formula, I will rewrite again 2 of 1, right, then 3 of 2, what else we have? 2 of 6, right. This is the given structural formula. And you know, structural formula is give information about the stages, right, and also the speeds aspect. There is one more information, the kinematic diagram indicate about the number of gears. It will indicate about the number of gears. For first stage, the first stage is 2 of 1. We talk about one input speed and 2 output speed, right, and also the distance between the 2 output speed, the within the bracket, that already know. The another information is it shows you need 2 gears in the first stage. In second stage, this is your first stage and 3 of 2 is a second stage and 2 of 6 is a third stage. Second stage, the formula 3 of 2, which shows you need 3 gears. And third stage, is 2 of 6, isn't it? It indicate about you have a 6 input speed and each input speed will give you 2 output speed and the 2 outputs should be placed 6 steps ratio apart, right. That was the information. Now, another information, you needed 2 gears. I think in the last lecture itself, we have mentioned number of gears. The total number of gears you would need for 3-stage gearbox is 14. The total number of gears, is 14 for this gearbox. GB means gearbox. Okay. Let me ask one more question. Okay. Before discussing about the construction of kinematic diagram, I want to give information about the size and the speed. If the gear size is big, what happens to speed? What about the speed? I am talking about relatively. And you have small size gear, you have small size gear. Okay. So, if the big size gear, obviously the speed would be low or small, right? We are talking about big and small. So, low speed. Okay. Now, small size means high speed. So, the size also very important. So, this is the cue, we are going to use it in the construction of kinematic diagram. Okay. And one more thing is, so this is a 3-stage, already know that the number of shafts you need for this gearbox is 4 shafts, 4 spindles. The number of shaft means the spindle also, I can say that the number of shafts in gearbox, machine tool gearbox, we say spindle speed. Spindle, right, is 4. Okay. And one more information, in ray diagram we use vertical lines, right, vertical lines for indicating the shaft. Here this is for the ray diagram, vertical lines. Here in kinematic diagram we are not going to use vertical line, but we would use the discontinued lines in horizontal direction for indicating a shaft in kinematic diagram. Okay. Now, move on to the kinematic diagram construction, stage 1. Okay, you can see here, this is the I want to take some information from stage 2. What does stage 1 consist of? The stage 1 consists of this shaft 1, this is your input shaft 1, we can say that shaft 1, shaft 2, okay, and shaft 3 and shaft 4. These are 4 shaft. So, my input is 1 speed, output speed would be 2 speed, isn't it? That is your formula. Okay, that is your formula. Let us see. So, my input speed should come from the motor. This is from your motor. Okay, and this is your desired output. What are the output speed here from the ray diagram? You always you have to use a ray diagram to construct the kinematic diagram. Okay, tell me what is the output speed you are expecting here? I would expect G and F. Okay. So, what is the speed is gives for G? 500 RPM. Okay. What about F? 350 RPM. Okay. In relatively, can we say your F gear is a small gear, because bigger gear, sorry, it's a F is a bigger gear, because the speed is low, right, it's a relative term, it's a big gear. Okay, it should be, size will be big, and obviously G is a high speed, the size would be smaller. Okay, small, just for understanding. So, usually what we do to represent schematically, we will have a kind of this kind of information. Okay, it's a relative though. So, one is smaller, another one is bigger. So, what this is bigger for the low speed gear speed. Okay, and this is for the high speed aspect. This is the way we are going to use it during the construction of kinematic diagram. Okay. So, now we know it's very clear, stage 1. So, we will go for the kinematic diagram actual. This is the shaft 1, spindle 1 and spindle 2, spindle 3 and spindle 4. So, normally we will have line like this to show, right, that is indicate about the shaft So, how many output you would expect here? Gearbox will have one output speed. So, what we are going to do, we will show this is the one as output, this is coming as output here. This is how we will do this. So, input, the motor will be, we will have a motor here. Okay, this is your motor. Okay, and you know that the structural formula is given 2 of 1, right? And already we have discussed in the previous slide, we needed 2 gears. Okay, one big gear, one small gear. Right, one big gear which is representing 355 rpm, my F, another small gear which is representing high speed G, 500 speed rpm. Okay, so they are always together. Remember, in machine tool by default the gear type is sliding. So when you say sliding, you always use a stick for moving the gear selection during the gear selection. A stick, a gear selector will be there, so that you have to slide. It's not automatic transmission, right? Or it's not a not only automatic or constant mesh or synchro mesh. This is a sliding mesh. So you have to move gear shift through shift and to get the desired speed. So in that case, so these are the coming from this first stage. So one is always mesh. Okay, what I did, one is always meshing. The other one, if I want to have another speed, right? What I should slide. When I want to slide, I should move to the another gear. So they have to place based on the phase width or thickness of the gear. This is called phase width. This, you know, this is the phase width. This is the phase width. So thus much distance you should leave as a gap with the little clearance, so that when you shift from this engagement between these two to the next engagement. Okay, and please understand that. So you always, the drive gears are movable, the driven gears are fixed. Okay, that means these gears are fixed, they won't move, they will fixed into the spindle 2. Okay, so this is what is the, now on the current mesh, what is the speed you would expect? 500 rpm, because of bigger size to smaller size. The moment you shift this one, right, when you shift this one, it will engage, these two engage. When these two engage, what happened to the speed? Will be 355. So because smaller gear to bigger gear, so the transmission, right. Please understand that the spindle should keep same center distance between two shafts. Between two spindle, the center distance must be constant. Of course, it can be same center distance kept for other stages also, or you can have different, but as long as the number of shafts are placed, one spindle should maintain the same center distance to the previous stage. That you have to follow. Yeah. Now it's okay, right? We have done for the first stage aspect. Okay. Now we'll go back to the stage 2, right? This is your first stage. This is your first stage. This is your second stage. And this is your third stage. Okay, so what happened to the second stage? What's the structural formula? 3F2, isn't it? Okay, 3F2. So you have 3F2. You needed 3 gears. That means one input will give three different speeds. Okay, let's check for G. I have G. Okay, I have taken the G. That will be the input to the my second stage. We get a 2 speed G, and I have G and F are both are 2 input speeds. What are the output speed I would expect for G? Okay, leave the G, I will go for F. For F I would expect C, D, and E, right? This is what happened. If you look at a C, it's 125 rpm. I'll put in bracket for easy to understand. Then if I do for a D, it's 250 rpm, okay, and E 500 rpm, okay. So you have to have a 3 different size. One is bigger, medium, and smaller, because this is the second stage, right? So this for the smallest speed, right? This is the next medium speed, and next highest speed. Like this we can have, it's a relative for understanding, right? It's a relative aspect we do. So like we did it for F, okay. Similarly G also will have same thing, right? G also will have the same thing, okay. The G would be, I can straight away will go for the speed. G would be 180, 355 and 710, right? 180, 355 and 710. So 3 speeds you would expect, okay. Right. So this is already we know, we have fixed for the stage 1. Now we are moving to stage 2. So we need a 3 gears. All 3 gears in drive should be together, right? So one, you can have a little smaller size, and another one you can keep it in the right side. So you can interchangeable, doesn't matter, okay. So one more thing, understand that again dynamics also will involve, but our focus is not about dynamics, about understand about the design, okay. The placing gear also very critical based on the dynamic analysis, rotation, balancing the mass, rotation masses, right? That is also there, okay. So that is also will plays a crucial place in kinematic diagram. However, we restrict only to understand how to place the gears. That's how we are going to focus. So now we have 3 gears, okay. So how we need again 3 gears? At least we will make one is meshing. This one is meshing. So currently it's meshing will give me, what is the speed I will get? I will get maximum highest speed, right? Maximum highest speed. Then if I move this direction, I can have this mesh will give you lowest speed. Again if I shift the gear to engage these two, I would expect the medium speed in between, right? So already we have gave the 3 range for F, so does G also, right? As aware of that, these gears are fixed, only the drive gears are shiftable, movable, okay. So this is the your arrangement for stage 2 kinematic diagram, okay. Right. So now go for the stage 3. We discuss about stage 1 and stage 2, stage 3. What is the formula stage 3? 2 of 6. 2 of 6. That is, for one input speed, you would expect 2 output speed, okay. So now we have how many inputs? We have C, right? We have E, D is there, and C also there. So we will take in the 3 actually. In fact you have in between also 1, 2, 3, 4, 5, 6. These are 6 input speed, and each input speed should give you 2 output speed, okay. For example, C will give me 2 speeds, right? Right, 2 supposed to be. So that is A, okay, and this is B, A and B. So A would be 31.5 rpm and B is 250 rpm, okay. So which is indicate about again high speed and low speed. That's it, right? So when you have when you want to have a high speed, the gear should be as small as possible, small. This is for high speed aspect, okay. And if you B would be for a bigger size, okay. Obviously you will have a low speed. So, same concept we are going to follow for the third stage also, right. So, this is constructed for the stage 1 and stage 2. Now, so one big gear, one small gear, that is what supposed to be happen, right. You can see that one big, one small. Okay. Now, I need to have a one mesh here. The other one is, this will give me the IS RPM, and if I move the gear shift to this way, I will get my minimum speed 31.5 RPM. Okay. So, in fact, these two are fixed. Anything you put as into mark which indicate they are fixed gear, they are not movable, they are always fixed to the spindle, corresponding spindle. Okay. Fine. So, now we have completed, okay. But still you can ask question, it's okay, we have constructed 2 gears and the first stage 3 gears, second stage and the another 2 gears second stage, but I don't understand how do I achieve 31.5 RPM. Fair question. Still I don't know how to achieve 500 RPM. So, what are the gears engaging if I want to get 31.5 RPM, right? So, if in fact, so this is complete one. Now, again we will go back here, this is fine. So, here, so what I am going to do for our own understanding, right, all the driving gears will have a odd number, all the driven gears will have a even number. So, I am going to say this is 1, okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay. Remember, all odd gears are drive gears, all the even gears are driven gears. Okay. So, which is for easy understanding. So, let me ask a question. I want to achieve 31.5 RPM. How do I do that? What are the gears need to be engaged? You can refer your ray diagram and also refer kinematic diagram. Can you tell me what is the way to do that if I want to have a 31.5 RPM? Right. Look, how do I do that? So, maybe let me do, I will try. So, I am giving you gear number 3. If the gear 3 and 4 engage, I will get the lowest speed. Am I right? Then, so that is it. So, my question is, so when the 3 and 4 are meshing, you will get one speed. The same speed will rotate in all the gears in the shaft 2. Right. This is shaft 1, shaft 2 and shaft 3, right, and shaft 4 is the other things, because all the gears are placing the same shaft, right. The 5 and 6 should have the same speed. Okay. Now, what is the next meshing? 9, 10, can we say 9, 10? 9, 10, okay. So, that is meshing. So, 3, 4 meshing and 9, 10 meshing. I want to have the lowest speed 31.5 RPM. The next one would be 13, 14. So, this should give me 31.5 RPM. Okay. So, can you check your ray diagram whether this is correct? If you follow the ray diagram, right. Now, are you able to understand why ray diagram, kinematic diagram very important? The ray diagram will talk about the speed flow, the kinematic diagram talk about the gear mesh engagement, right, the power transmission, both are there. Okay. Let me ask another question. How do I get 125 RPM? So it's much easier when I say 31.5 rpm, because I have chosen the small speed, so I can go for the all the bigger gears and engage. That is easier. Now I am asking intermediate speed 125 rpm. So what are the gears missing to get 125 rpm? Right? What are the gears? Can you tell me? You can refer your ray diagram. Okay, you can refer your ray diagram, and by looking at the kinematic diagram, you can tell about which gears should mesh to get the 125 rpm. Maybe I would say start with the 3-4 gear 3 and 4. Okay, then would you expect 9-10 or 7-8? 7-8. 7-8. Okay. So that is first stage 3-4, right? What are the speed as a 4 will have the same speed for a gear number 7, okay, because they are in the fixed in the same shaft, spindle shaft. Now 8, okay. So what is the next one? 13-14. Excellent. So now, okay, maybe I'll ask one more question. How do I get 1410 rpm? So last thing, I want to get 1410 rpm. So can I have answer for that? If I want to have a 1400 rpm maximum speed, because already we know that 31.5 it's the lowest speed. We have taken the 125 rpm as a intermediate one. Now I want to choose the maximum speed. So what are the gears must be engaged to get maximum speed? 1 to okay, excellent. So we'll go slowly. 1 to gear 1 and 2 should mesh. Then from here it should be 7-8. Because of the 8 is the highest speed. 7-8. Excellent. Then 11-12. Can you see that? So in the last, someone answered you needed 20 gears. We don't need. Though we have 12 gears, by having additional 2 gears, we are able to achieve all 12 speeds. Right? That is possible due to your progression, right? Progressive gears, right? That one thing, that is a very critical aspect, and with the help of ray diagram and kinematic diagram, we are able to achieve it. Okay. So now the next thing what we are going to focus, the number of teeth aspect. Okay. So number of teeth, we need to understand each gears, we need to find out for each gear. Of course, we are going to use 2 ways you can approach. Generally, as the beginning of the lecture I said, we will use the center distance, right. So assuming that for gear between 1 and 3, 2, 4, 5, 7, 9, they should have the same center distance, otherwise it's not possible. Okay. Similarly, if you look at 6, 8, 10, 11, 13 and 12 and 14, they should maintain the center distance, right. So there may be center distance, different center distance, doesn't matter, but within, when the meshing, they have to maintain among the gears having same center distance, then only the size can be maintained, the speed ratio can be maintained. Okay. That is what we are going to do in next class, finding out the number of teeth. Okay. Thank you.